Okay, I am super excited about this lesson. So this lesson, we are going to look at the relationship between confidence intervals and significance tests. So this is really where we put it all together. Okay, so here we go. We're just going to dive right in. It says a recent study suggests that 77% of teenagers have texted while driving. A random sample of 50 teenage drivers at the school was taken and 33 admitted to texting while driving. Assume all conditions have been met. So we get to cut that out of our analysis. Use your calculator to answer the questions below. Okay, so we have two parts here. We have part A, which is construct a 99% confidence interval, and part B, conduct a significance test. So we're going to do both of these here. So here's what we know. It says a random sample of 50 drivers. So my N value here is 50, 33 admitted. So X is going to be 33. We have this confidence interval here. So we have confidence interval is going to be 99%. Let's see what else. Okay, so this is a recent study suggested 77% of teenagers have texted while driving. Y'all, this is our claim. This is going to be part of our null hypothesis. So this is going to be my P naught right here. Okay, so we don't use that number. We're using this number for 99% confidence. Okay, so the other thing that I know here is that we are going to use a 1 prop Z interval. That's the test that I'm going to use. And I can go ahead and plug all of this directly into my calculator. It says use your calculator to answer the questions below. Okay? Sorry, had to get my calculator. So here's what I'm going to do. I'm going to go in here, clear this out. I go into stats, test, one sample Z interval, so number A right here. My X value is 33, my N value is 50, and my confidence level is 0.99. So when I run this, it gives me my interval, and it says 0.487 to 0.833, and this gives me this p hat of 0.66. I don't really need it, but I have that value. Okay, so I just ran this one sample Z interval. Here's what I have. So what does this look like? Let's go straight to our conclusion. So we are 99% confident that the true proportion of teenage drivers who have texted while driving is between 0.487 and 0.833. Boom, we're done. We've identified it, we calculated it, we've got everything here. It tells us to use our calculator. I don't even have any other data that's in there. Okay, so now let's go over here and look at the significance test. Conduct the significance test to determine the proportion of teens who texted while driving, if the proportion of teens who texted while driving is different than 77%. Use a 1% significance level. So, significance test, my null hypothesis, P equals 0.77. Now, this just says we want to determine if the proportion of teens while driving is different. So my alternative here is going to be not equal to 0.77. It doesn't say anywhere in here whether it's greater than or less than or whatever assumption we're making. We're just saying it's not 0.77. So this is going to be, when we get in here, this is going to be a two region. We're going to have two regions when we look at our p-value. Okay, so what else do we know? We know that our p-naught value is 0.77. We still have that X is 33 and N's 50. We also know that alpha is 0.01. Now, this is kind of interesting. So remember, here's our confidence level at 0.99 or 99%, and here's our significance level at 0.01. And remember, these two values have to add up to be 100%. So this is technically 0.99, right, and 0.01, which gives us 100%. So we're good. Okay, so what are we doing? we're running a one prop z-test. So that's what we're running. So when we do this, again, it tells us to use our calculator. So we're going to go ahead and do that. So when we have this, we can go in and we can look at stat calc one prop z-test. And my p-naught value that I have is 0.77. My x value that I have is 33. And my n is 50. And all I'm saying here is that it's unequal to p sub naught, right? It's not less than or equal. And if I go down here and do calculate, here's what I get. So this gives me a z-value of negative 1.848. However, we don't need this. We don't need this for anything because it gives us our p. So this value here, p, which is really our p value, is 0.0646. 0.0646. It gives us our p hat, which we already know because we had it over here, right? But this value is our p-value. This p is our p-value. So I want to show you this because I think it's important. If we look at our normal curve and we have this value, what this is saying is negative 1.848, and I have this value here of 1.848. This region that I have right here, so this value right here would be our rejection region. Let me write this as rejection, R-E-J-E-C. Rejection region, and this right here would be our rejection region. So if we look at just doing our normal CDF, so I'm going to go in here and look at our distribution, normal CDF, and I'm going to use an upper bound of negative 1.848. And when I do that, I get this value. But remember, that's just this lower bound. So when we have two regions and we aren't using our calculator, we have to show all of this data. We would take this and double it. So I'm going to multiply it by 2, and that gives me this upper region as well. So our p-value here that we calculated with the calculator was 0.0646, and using our normal CDF, we get this value 0.0646. So we got the same number whether we're using the our z-statistic or the calculator to find that value. Okay, so let's look at our justification. So here's what we want to say. Because our p-value is higher than alpha. Now, look at this. We have 0.0646, which is greater than 0.01, right? So because of that, we fail to reject our null hypothesis. So we do not have convincing evidence that teens who text and drive is different than 77%. All right, so what type of results did you get from the confidence interval and the significance test? Well, so here's what we have. So if I draw my curve again here, I know that my confidence interval, which is 99%, so this is my 99% interval, okay? And what I know is that this goes from 0.487 up here to 0.833. And this value of 0.77, which we're saying is our true proportion here, that value is a possible value here, that this lies between these two numbers. So our confidence interval contains 0.77 as a, here's our word again, plausible parameter which agrees with our significance test. Remember, we did not, we failed to reject. So we said that this value, everything that's in here, is what we don't have convincing evidence that says that we need to go to this rejection region out here. So that's why we failed to reject, and this worked. Okay, so the significance test said that 77 was a plausible result, and we see that value fall within our confidence interval. Okay, so that makes sense. It all worked together. So what does this look like? So we know that our confidence interval is 100% minus our significance level, right? So we've been talking about that. So what this means is if we're at 100% and we have this, then this value that we have here, it only agrees when we have this as unequal. If we have a 90% confidence level, then we have 10% significance. So 5% would give us a 95% interval, and 99 would give us a 1% interval. So if the significant level is not given, then just work backwards from whatever confidence interval they give you. Okay, if the confidence interval contains the null hypothesis, so we just showed that. The confidence interval contains the null hypothesis from a two-sided test, right? So I've got this region and I've got this region, a two-sided test. Then we're going to fail to reject the null. And that's what we just did. If the confidence interval does not contain the null hypothesis, then we need to reject the null. Makes sense, right? If our value that we were looking at would have been over here, we would have rejected the null because the null hypothesis says that this is the region that our true proportion is going to lie. All right, so let's look at how this all goes together here. So Scott's Turf Lawn Builder makes a claim that when plant users use their grass seed, 88% of the seeds will germinate. The germination rate of seeds is defined as the proportion of seeds that, when properly planted, fertilized, and watered, sprout and grow. The company regularly tests this claim to make sure its product is efficient. They plant 500 grass seeds in their fertilizer and find 412 of the seeds germinate. Assume all conditions are met. What is the 95% confidence interval for this observation? So here's what we have. 412 germinated. So we had success with 412 of them. They planted 500. And my confidence interval here is 0.95. So when I run a one prop Z interval, let's see what results we get. So stat, test, one prop Z interval. So I had 412 out of 500 and a 95% confidence interval. So this gives me an interval of 7906 to 0.8574. And I'm just going to write this down. I don't know if I'm going to need it later, but this gives me my p-hat of 824. And remember, your p-hat is going to come from this value of 412 divided by 500. Okay? All right. Suppose the company conducted a test and said that our null hypothesis is 88%. Okay? That's what it says up here. 88% of the seeds will germinate. So H naught says that P is 88. Against the alternative, which is just that it's not 88. We don't know if it's bigger, we don't know if it's smaller. It's just not 88. Using a significance level of 0.05, use the confidence interval to determine whether this test would reject or fail to reject the null hypothesis. Okay, so this is great. This is what we have. We've got this curve. We know that this value is 0.7906, and this value is 0.8574. Okay, this is my 95% confidence region. So that's this region that's right here. And the value that we have here is 0.88. Well, our 0.88 value is going to be over here. Okay, now remember what we've got when we do this is we're saying it's not this. So this is a region that we care about, and this is a region that we care about. So because of this, what we have here is this is not a plausible value. And so because we're outside of this region, we are going to reject, we will reject H naught in favor of our alternative hypothesis, H sub A. We can say we have convincing evidence that the germination rate is not 0.88. Now, don't say that it is greater than. It is greater than. We're just saying it's not 0.88 because it's going to be any value that's in here. Yes, this is outside the region, and that's all we want to say is that it is not 0.88. All right, so find the p-value for this test, explain what the p-value measures in the context of this problem. So I'm just going to use my calculator, and I'm going to go in here and run the test. So I have stat, test, I'm doing a 1 proportion z-test. So my p naught value that I have is 0.88. That looks like that's all good. They pulled that from the previous one. And so what I get here is that my p-value is 1.165. Okay. Oh, keep looking. Times 10 to the negative 4. So this e to the negative 4 is saying this. So what this really is 0.12341 7. So that's my p-value, which is technically 0. My p-value is technically 0. So here's what this is saying. So it says, explain what the p-value measures in the context of this problem. So the probability that, remember this is important that we talk about numbers, that 412 seeds out of 500 will germinate. The probability that 412 seeds out of 500 will germinate if 88% of seeds actually germinate is 0.000117. So pretty much not. So therefore, if we look at our numbers, we have 0.0001, and this value, when we compare to we're at 95%, so this value is way less than 0.05. So when our p is low, we reject the null. Therefore, we're going to reject our null hypothesis. Okay, so we saw that up here. We rejected it because it was out of our confidence interval. We can reject it in this case because our p-value is way smaller than our significance level. And so what happens, again, what we've measured is the probability that 412 out of 500 seeds will germinate if 88% of the seeds actually germinate, and that's because we're dealing with this 88 as our null hypothesis, is 0.000117. Okay? So super fun how this all comes together. Okay?